So in this section we're going to learn about how to use the product rule to take derivatives of some functions that we have not been able to take the derivative of so far. So the product rule is that if we take the derivative of f of x times g of x, then we have to do f of x times g prime of x plus g of x times f prime of x. So our first examples ask us to find the derivative of y equals x squared times cosine x. So in this case, we're going to let our x squared, that's going to be our f of x. And we're going to let this cosine x, that's going to be our g of x. So in order to take the derivative of these two things multiplied together, we have to use the product rule. The biggest mistake I see a lot of students make is they just take the derivative of both of these separately, which we cannot do. We have to use this product rule. So we're going to have y, or the derivative dy over dx equals, and then we have to have f of x, so that's just our x squared, times, that's our f of x, and we have to multiply that by g prime of x. So g prime of x, the derivative of cosine, is negative sine x. Then we have to put a plus sign here, like we see here in the formula. Then we have to take g of x. So g of x is going to be cosine of x. And then we have to multiply last by f prime of x, so the derivative of x squared, which is 2x. So for this problem here, we're going to have dy over dx equals negative x squared times sine x plus 2x times cosine x. I'm just cleaning that up a little bit. Typically you're going to see these variables in front of your trig functions, and there's really nothing you can do to combine any of that, so you would just leave your answer as you see it here, and this would be our derivative of x squared times cosine x. Our next problem is 3x minus 2x squared times 5 plus 4x. Now, you do already know how to take the derivative of this. You could multiply this stuff together first. So I'm going to show you that way first. So if you wanted, you could distribute. You would get, not taking the derivative yet, you would get 3x times 5 would be 15x. And then we'd have plus 12x squared minus 10x squared minus 8x to the third. And then, of course, there we could combine the 2x squared, so we have there, so we have 15x plus 2x squared minus 8x to the third. And when we take the derivative here, we would get 15 plus, I'm sorry, that should be squared right there. We'd get 15 plus 4x minus 24x squared. That would be our derivative. It might be written like that. You also might see it written negative 24x squared plus 4x plus 15 also. So you can do this the way that we have already learned, just expand and then use the power rule. But we could use the product rule also here. So if we use the product rule, then we would need an f and a g function. So we would have our product rule tells us that if we're taking the derivative here, we need that the derivative is going to equal f of x times g prime of x plus g of x times f prime of x. So in this case, we would would have f of x, which would just be 3x minus 2x squared times g prime of x. So that's the derivative of g of x, and the derivative of that g of x here would just be 4. Plus g of x, so that would be the 5 plus 4x, and then f prime of x, so the derivative of f of x, which would be 3 minus 4x. And so we would simplify this. We would have to distribute that 4, so we would get 12x minus 8x squared. And then over here, we would have to multiply together here, so we'd get 15 minus 20x plus 12x minus 16x squared. So whenever we combine everything that we have here, we could put together this negative 8x squared and that negative 16x squared. That's going to give us the negative 24x squared. Then we could combine the 12x, the negative 20x, and the other 12x here. Well, 12x. And so that is going to give us the plus 4x, and then you got that plus 15 on the end. So either method works here. I actually probably prefer that first method that we use right here in this case, but I just wanted to show you another situation where this could be used. Our last example is going to be f of x equals 3x sine x minus 2 sine x. And so for this problem, you've got two things separated by a minus sign. So you can take the derivative of this first part separate from the second part. The first part is going to require a product rule because you've got 3x times sine of x. So you got some expression with an x times some other expression with an x. So you have to use a product rule for this. So we're going to have f prime of x is going to equal, we'll have 3x times the derivative of sine x, which is cosine x, plus sine x times the derivative of 3x, which is 3. And so this gives us the derivative of just this first part here. We also have to take the derivative of the minus 2 sine x. The product rule is not necessary here because that 2 does not have an x with it. That 2 is just a coefficient. So here the derivative of sine x is cosine x. So we get minus 2 cosine x. And so if we clean this up a little bit here, we're going to have 3x times cosine x plus 3 sine x minus 2 cosine x. And we really don't have anything else that we can combine here. Even these, both of the cosine x, we have a 3x and just a 2 here, so those cannot be combined. So we would just leave our answer like this.